Hello guys. So today we are going to learn something about the concepts of digital logic design and we at the Bennett University Computer Science Department usually upload the different tutorial sheets to help the students. So we will start from this tutorial 1. Okay, so the tutorial 1 is all about the basic concepts about the number systems, the conversion from one number system to another. So that's what we are going to see in this lecture. So let us start in the tutorial 1. Okay, I'm going to skip this question 1 that discuss briefly regarding the need of different number systems. Okay, so as we know, there are different number systems available. Like the foremost is the binary number system, uh, which is used in our digital computers. The binary indicates only two states like 0 and 1. So it is also called as a base 2 number system, and the base 2 indicates that the numbers can go up to 1. So if we talk about the decimal number system, which is having a base 10, so we can say that the numbers can range from 0 to 9 because our base system is 10. So 10 is not possible. Okay, but with the help of those numbers in 0 to 9, we can create the subsequent numbers. So apart from this binary number system and the decimal number systems, we have the other number systems which we frequently used, such as the octal system, where the base is 8 and the range of numbers are 0 to 7. Similarly, we have the hexadecimal number system, where the numbers can range from 0 to 15, and the numbers from 10, 11, 12, 13, 14, and 15 we represent using A, B, C, D, E, and F respectively. Okay, so the need for the different number system is that, okay, so in our conventional or day-to-day life, we are habitual to use the decimal number system. That is a base 10 number system. All our computations like addition, subtraction, multiplication, divisions, we used to carry those calculations in the decimal number system. And as I already told you that the decimal number system is having a 10 different states range from 0 to 9. So in order to distinguish those 10 values, we need a 10 different discrete values. Okay, so which is quite difficult to mimic in our digital system. That means we need a 10 different voltage level. Okay, we can say the thresholds to distinguish the number 0 to 1, 1 to 2, and so on. However, if we use the binary number system like the base 2, so we need to mimic only the two different voltage level, and using those two levels we can distinguish the 0 and 1, which are the possibilities in the binary system. So that is what the need for the different number systems in our case. Now I'm going to about discuss about this second question, that is a convert the number given in the base 2 number system to base 10 number system. Okay, so here as we can see the number is in base 2, that means all the values in this number cannot exceed the 1. It means it has only the number 0 and 1, and we need to convert that number into the decimal. Okay, sorry for the interruption. So here we are going to convert the binary number into the decimal number. Okay, so usually what we need to do when we convert the binary number into the decimal number, we need to see and the number in a binary, and we start multiplying each digit in the binary with the 2 to the power something, and that something depends on the position of that digit. So we usually start with the 2 to the power 0, then 2 to the power 1 for the next number, then 2 to the power 2 for the third number, and so on. And then after we simply add those numbers. So what we used to do is like this way. So the number in a binary is given over here, and we start with the 2 to the power 0. Since this least significant digit is 1, so we multiply with them. Okay, then we add, then take the another digit. So then the next digit is 0, we multiply with the 2 to the power 1. So we start with 2 to the power 0, then 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. So this way we keep on raising the bar. Okay, and we multiply with the digit, and finally we add those to all the number. So 2 to the power 0 is 1, so 1 multiplied by 1 is 1, then 0 multiply anything is 0. 2 to the power 2 is 4, multiply by 1 is, so this means 4 plus 0 plus 1, so ultimately 5. This one is also 0, so 5 plus 2 to the power 4, 16. So 16 plus 5 is 21. So this is the way you can convert the number from binary to the decimal. So let us say we take the reverse process. That means a number is given in a decimal and we need to convert that number into the binary. So how do we supposed to do that? So we used to do the complete reverse process. So instead of multiplying the number, we divide that number by 2. And each time when we divide the number, we used to note down the quotient and note down the remainder. Okay, and then we take the quotient again, and again that we divide that number by 2. So we keep on dividing that number. Okay, so let us start from the 41. Okay, so first of all 41 divided by 2, because we want to go into the binary number system. So 41 divided by 2, so that means 20 will be the quotient and 1 will be the remainder. Okay, so that means 20 multiplied by 2 is 40, so 1 will remain, so that will call as a remainder. So now we take that quotient again and we divide by 2. So 20 divided by 2 is a 10 is a quotient and remainder is 0. Again we take the quotient 10 divided by 2. So 10 divided by 2 is equal to 5 is a quotient. Again the remainder is 0 in this case. Okay, now we take the 5 as a quotient and divide it by 2. So 2 will be the quotient and 1 will be the remainder. Again we take the 2 as a the number and divide by 2. So again the 1 is a quotient and 0 is the remainder. Okay, now 1 is still means when we have to stop this process when the quotient will be equal to 0. As you can see, the quotient is still not 0, the number is 1 over here, so we divide that 1 by 2. So now in this case the quotient will be 0 and that the very number will remain as output, so the remainder. So now we can see we have the quotient 0 and we need to stop this process of division. Okay, so now we get those reminders like 1 0 0 1 0 and 1. Now the fundamental thing or the requirement from the decimal to binary is that whatever the reminder, the order we get, like in this case we get the order is 1, then 0, then 0, then 1 0 and 1. Okay, so we need to write this entire number in a reverse order. That means we start from the last reminder, so then we put as 1 over here, so 1, then the next number is 0, so we put as 0, then 1, then double 0 and then 1. So this will be our actual binary number of the decimal 41. Okay, if you want to make sure that the things are working or not, okay, so what you can do, you can do the reverse process like this. Suppose you get this number binary as an input, so apply this process like the least significant digit, multiply it with the 2 to the power 0, and each number, if you move towards the left hand side, just increase the power by 1. So 2 to the power 0 we start, then 2 to the power 1, 2 to the power 2, and keep on going with that. Okay, so when you will do that process, you will ultimately get the number 41 as an output. Okay, so these are the two simplest example to switch the number between the systems, like from the binary to the decimal and from the decimal to the binary.